All right, it's time to do some practice problems with friction. So here we're just going to focus on no angles. Okay, so this is a straight up friction problem. So the scenario is that you have a block and it is sliding to the right at a constant velocity. We know the coefficient of friction between the ground and the block is 0.4. And your job is to tell me what is the mass of the block if it's being pushed down with 70 newtons of force and being pushed to the right with 50 newtons of force. All right, so try the problem, see where you get, and pause the video and come back, check your answers, see if you're on the right track, see if you need extra guidance. So on your mark, get set, study! Oh, and pause. You should do that too. Yeah, pause the video. No, seriously, pause the video. Okay, this is full spoilers. If you've not paused the video by now, then that means you just want the answer. So here you go. Here is the answer to your problem. It is... I should write with something that makes writing things. Let's try that again. Okay, your answer is mass is 5.6 kilograms. So if you got that as your answer, then you are well on your way to victory. If you did not get that as your answer, then the first thing I'm going to say is check your force diagram. So here's your force diagram. Did you get a... Let's get that out of the screen here. How do you just delete it? Let's do that. Just delete. There's a button somewhere. Cut works too. There we go. Yay, it's gone. So you should have a force diagram that looks like this. You should have 5 forces on it. You've got the ground pushing up. Don't forget your own notation. I'm just being lazy here because, well, I've earned that right over time. Then you've got the 70 pushing down, the 50s pushing to the right, friction is pushing to the left. These two here have the same on-by notation. Let's do a color change of red. So this is force normal on the object by the ground. This is the force of friction on the object by the ground. So these are the two that are linked together. So you need to first find the normal force to find the force of friction. There is mg because that's the gravitational force, all pulling it down. Balanced forces everywhere because we're traveling at constant velocity. So hopefully that helps. So if you need to, you can pause it, try and crunch some numbers now if you didn't have the right force diagram. But if you did have the right force diagram and you still didn't get the right answer, then let's look at that math. So here we go. Here's the math. Let's just get rid of that. Ta-da! So first thing I did right out of the gate was I just wrote out net force equations in the x-plane and the y-plane. Paused myself, centered myself. Then I referenced my force diagram, listed the forces that I saw in the appropriate planes, and then started solving. Now, I knew going into this, these two forces were linked. So in all honesty, I did start in the x-plane because I was looking for this mass right here. So I knew I was going to have to kind of take this path, find the force of friction, find the normal force, then find the mass. So I started in the x-plane with my brain. Could have started anywhere though. Solve out, you get your normal force of 1.25 or 125 newtons. Then that gets used over here in the y-plane. The only unknown is mass. Do some algebra, you get your 5.6 kilograms. So hopefully you found success, or at least you found your mistake, and that's going to help you on the assessments. So as usual, if you do have questions, come on and say hi, or maybe check out the video a second time. But either way, enjoy your science experiences. See you later, folks.